This time, we have two matrices here which are actually 3 by 2 matrices. And again, the goal here is to come up with the basis of the range of these two matrices together with the rank. The basis, again, of the range of these matrices is equal to the column space of both matrices. Column space meaning the columns in our initial matrices that contains pivot columns or leading ones once we come up with equivalent reduced row echelon forms. So to start with, let's have here our matrix A, this first matrix. I'm just going to copy it first. 1, 2, -1, -2, 1, and 1. Before we proceed, notice that our first and second columns are multiples of the other, or in short, the second column is the -1 of our first column. And we have learned before that once we have columns of multiples, we expect that there is a row of zeros. But we can see that as we proceed here with our reduced row echelon form, since we already have a leading one, what we need to do is to make the 0 as well as this. To make -1 be 0, simply add row 1 and row 2 for a new row 2. For our third row, multiply -1 to R1 plus R3 to have our row 3. Okay, so this is still 1, 2. Now, simply add, you will have 0. Simply add, you have 0. As mentioned, since row 1 and row 2 in our original or initial matrix are multiples of the other, we have here a row of zeros. Let's just continue. -1 times 1 is -1 plus 1, 0. -1 times 2, -2 plus 1, -1. Since we have here a row of 0, and for the reduced row echelon form, the row of 0 must be on the bottom portion. So simply interchange row 2 and row 3. So with that, we can have here 1, 2, 0, -1, 0, and 0. Finally, not finally, the next step is to make this a leading one. Simply multiply -1 to our row 2. So we have here 1, 2, 0, now +1, 0, and 0. The last step for the reduced row echelon form, since the idea of a reduced row echelon form is that once our column contains a leading 1, all other entries must be 0. I'm talking about this. Let's make that 0 by multiplying -2 to row 2 plus row 1 for a new row 1. Hence, we'll have here this is still 0, 0, that's still 0, 1. This is still 1 because -2 times this is just 0, then plus 1. And then -2 times 1 is -2, plus 2 is 0. This is now our reduced row echelon form. Looking at this, both rows contains leading 1. In short, they are both pivot columns. Once we have identified that, these same columns on our initial matrix here, this column and this column as well, comprises our column space, and that column space is equal to the basis of the range of this matrix. So our basis now, let me rewrite it here. The basis for the range of T is a set containing those two columns, 1, -1, and 1. So you have here 1, -1, and 1, and you have 2, -2, and +1. Or you could also rewrite it in this manner. You have 1, -1, 1, and you also have 2, -2, and then 1. This is the basis of the range of the first matrix. The rank of T here is actually equal to the dimension of the basis of your range. Our basis here contains 2 vectors, so our rank is also equal to 2. So this is the answer for the rank. These two are acceptable bases. But of course, there is one more, or there are other forms of bases as well. Since we're using here the column space, once you will use the row space or the idea of row space, you will also have a separate or a different form of bases. Nevertheless, both of them are accepted. Let's just stick with this because this is one of the most commonly used process, the column space. Then, let's do the same thing on the other matrix. We have here 1, 1, negative 1, 2, 0, and 1. Let's make the 0 by adding row 1 and row 2. No need to manipulate that because that's already in 0. So 1, 1, you add them up, 0, you add them up, 3, you have here 0 and 1. Now here, it's up to you which process you would like to do. You can always interchange the row 2 and row 3 or multiply first 1/3 to our row 2. Nevertheless, my suggestion here is just to interchange row 2 and row 3 so that in our row 2, we already have a leading 1 here. And that means we can apply a certain process to make this 0 as well as this at once, because for this to become a reduced row echelon form, once we have already identified a leading 1, all other entries on the same column must be 0. So first, you can multiply negative 3 to row 2 plus row 3 to make this 0. And you can also multiply negative 1 to row 2 plus row 1 to make this 0 as well. So you have here 1, 0, 0, because when you multiply both of this to 0 here, it won't change the values. But for this second column, negative 3 times 1 is negative 3 plus 3, 0. Negative 1 times 1 is negative 1 plus 1, 0. So our matrix here are reduced row echelon form, which is the same as the previous. In short, both columns here also considered to be part of the column space, but we're going to focus or refer on our initial matrix here. Hence, our basis for range here is a set containing those two columns earlier, 1, negative 1, 0, and 1, 2, and 1. Let me check. 1, negative 1, 0, 1, 2, and 1. That's correct. Okay. Or you could rewrite in this manner. 1, negative 1, 0, and then 1, 2, and then 1. So this is our range of T, or the basis for the range of T. Hence, our rank of T being the dimension of the range, or the basis of the range. We have two vectors. The answer is also 2. This is the rank, and these two are acceptable basis for the second matrix. So this is how we solve the range and rank, or the basis for the range and the rank of these two matrices here. So that's all, and thank you very much for watching.